Okay, tangents and their properties. So remember, a tangent is only touches a circle once. So if I'm drawing a tangent, draw PQ extending past Q, then draw a tangent to the circle at point Q. So this is my tangent. And it only touches the circle at one spot. And so it's always perpendicular to radius / diameter. So that means when we're talking about tangents, we have always have a right angle right there. So always have a right angle. So basically we're looking at right triangles. So in number 1, we're looking for the radius. So we have 13 squared minus 12 squared equals x squared. 13 is the hypotenuse. 169 minus 144. 25. So x equals 5. All right, and then I wonder if this one comes out easy. This one we're looking for a leg. So, oh no, we're looking for the hypotenuse. So we have 7 squared plus 24 squared equals x squared. 24 squared is 6,590. Let's just see if it works. 24, oops. 576. So I have 49 plus 576 equals 625. 625. Oh, whoops. That's x squared. So that means x equals 25, because I know 25 times 25 is 625. Okay. If two segments are tangent to a circle from the same external point, then they are congruent. So if we have a point out here somewhere, and I can make tangent lines, kind of, sort of, okay, let's erase that dot, because that's not even close. So let's say if I have a dot right here, then that means that this and this are equal to each other at that point of tangent. So really, we're talking about, like at number 4 when I'm looking at it, we're really talking about this segment being x plus 8 and this segment being 3x plus 2. So I'll just do them out of order since I'm already looking at this one. So 2x equals 6, x equals 3. So that means that 3 plus 8 is 11. 3 times 3 plus 2 is 11. So it checks out. Okay, so basically number 3 is just a whole bunch of tangents. So what that means is this guy and this guy are both going to be 3. See how many different colors I can use. This guy and this guy are both going to be 4. This guy and this guy are both going to be 2. And what on earth do I know about Z? So x is 2, y is 4. Because CD does not have to be 4. Do I have to do some kind of right triangle? I don't think that helps me at all. Oh, because they told me something like that. And I wasn't paying attention. So if I know that this whole thing is 6, then this is 3 also. So if I had been paying attention, I would have gotten that much quicker. All right, external tangents. Common external tangents look like the line that's tangent to both and an internal tangent goes, let's see if I could do this like that. Oh, that's not horrible. Okay. So if we have a common external tangent, that means we have two, remember this is a right angle, this is a right angle. We have two similar triangles, and so we can do a proportion. So these guys are proportional. And remember, we need the whole thing, so we need 12 plus y. So we have 5 over 10 equals 12 over 12 plus y. Well, since we know that 5 over 10 is the same as 1/2, then we know that y needs to be 12 because we need 12 over 24. So that would have to double it. All right, and same thing here. We're going to have 4 over 12 equals 6 over 6 plus m. 4 over 12 is 1/3? No, yes. So that means that 6 plus m, so 18 equals 6 plus m. We'll do a little cross multiply. And subtract 6, so m equals 12. All right. So now we're going to put some of this together. We have an external point and two tangent lines. PT and QT are tangent segments. That means they're equal to each other, which means that these are equal to each other, and these are equal to each other, and those are the radius. Okay, so if QT equals 30, then TP equals 30 also, because those lines are congruent. If OQ equals 9 and QT, okay, now we have a triangle with a right angle. So OQ is 9 and QT, so we have 9 squared plus 12 squared equals OT squared. So we have 81 plus 144 equals 225. So OT is the square root of 225, which is 15. Alrighty, the diameter of O is 10, so that means the radius is 5, right? And OT is 13. That means we have 13 squared minus 5 squared equals QT squared. So we have 169 minus 25 is 59, 49, 44. So QT equals 12. Alrighty. And PTO is 35. Find TOQ. Okay. So that's 35. That's 35. That's a 90. So TOQ is going to be 90 plus 35, 125. So then we're going to do 180 minus 125. 35, 45, 55, 65, 75, 55. So the measure of angle TOQ equals 55 degrees. All right. And the last really fun thing to draw. Okay. A circle is inscribed in a polygon, so the circle is inside. And each one of the lines is tangent to the circle. So let's try this and see if I can do it. So I mean, I could do a triangle, I could do a square, there's a triangle. Okay, and then you're going to assume that each one of those points is just one point. Okay. Circumscribed means that each one of the corners is on the circle. So circumscribed, outside, inscribed, inside.